Morning friends. Today we'll be going to the secondary treatment. Till now we had a primary treatment. Usually sewage has primary, they classify it as primary, secondary and tertiary. It is there for everything, be it your drinking water or your wastewater. It's all depending on what you are trying to remove. When you're looking at sewage in particular, secondary treatment is fundamentally your biological processes. Some biological agents are there. First process, it was mainly by the action of gravity. Water will just flow through gravity, with the help of gravity through screens. Then you may have a clarifier. Settling is again by gravity. So basically all the units in a primary treatment are worked by gravity. If you look at the process, or if you look at any standard handbook of wastewater engineering, they give this definition. Now, secondary treatment has biological activity as the moving force of this. So moving force means what actually does the work, biological agents. Then it provides BOD removal. Okay. So whatever is the thing that requires biochemical oxygen demand for oxidizing, that's taken care of by secondary treatment. Then the effluent, whatever goes out of the secondary treatment, is stable. What do you mean by stable? It means that the state in which it is coming out, it will retain. As in, most of the biochemical activities are already over. So it will not become more septic than what the state it is in. And also it is low energy. It means that there is no food available for some organism to live on. So nutrient removal is there. Nutrients give energy basically. Okay. Be it an aerobic process or an anaerobic process. If you have an aerobic process, you will have carbon dioxide and stuff like that released. On the other hand, if suppose it's an anaerobic process, there may be some nitrogen, phosphate, all those things involved, but end of the day you get methane, which is the end product. So basically what happens, the bacteria takes it, eats it and releases something else. Okay. So these are some of the common techniques. Activated sludge process, trickling filters, these are there in your syllabus. Directly they have mentioned it. And then rotating biological contactors and oxidation point. That is, this rotating biological contactors are not specified in your syllabus, but I will put it under that other treatment methods. Okay. And oxidation ponds is nothing but a stabilization pond. Okay. So now basically whatever we do here, we try to make it into an aerobic process. Normally the sludge is digested under anaerobic conditions, or the biomass which is really out of a process. You sediment, whatever comes out is a biomass, that is done under anaerobic conditions. Here also, whatever is the biomass that gets generated, that is taken for further treatment in the sludge handling processes. But if we go for tertiary treatment, it might be something that makes the water more clear. Maybe some ultrafiltration or something like that is done to make it better. Okay. So then these are the things which I think I have already told. Here we go for the activated sludge process. Okay. So activated sludge process is used for only for biologically degradable waste. It means that activated sludge process can be used for the waste from a sugarcane industry, but for a tannery it is not possible, because it will have heavy metals and all that which will kill the bacteria. Okay, so this sort of an understanding is very much important in the choice of a process, and in this case activated sludge process, we needed to be something with a lot of bio content, a lot of BOD content, especially BOD 5. There's something BOD 5, BOD 21. You can also go for much longer periods of determining a BOD. Okay, but BOD 5 is the place where you have mostly all the biological substance. And whatever you get out of this system, effluent of the activated sludge process, is called as a mixed liquor. Okay, it is a high quality effluent which has a lot of suspended materials. Okay, stable suspended materials, more or less now homogeneous distribution, more or less in a homogeneous distribution. And what is this suspension made of? A lot of microorganisms. So basically, you will require to have a sedimentation and a filtration process after you have a activated sludge process. Clear? So these two processes should follow the activated sludge process wherever possible. So whatever goes out is carbon dioxide and water. Okay. This is a this is a scheme. So what happens here is the sludge is taken back. Okay, so that it becomes more. That is, sometimes you may find that the effluent is having a variable quality. So the quality might be having lesser microorganisms. So at the time you recycle it so that you are having a constant loading rate. In fact, this one requires a lot of what shall I say? It requires a lot of air, and also it has to be kept wet. Okay. I was looking at a video of a person. I didn't want to show that because if you want to see it, you can very easily see it. Who did that was around 14 minutes. Okay, so it was too long. I didn't want to show it. But if you look at it, it will give you ideas for your projects if you require. I mean, in the sense that see how simple it is to make it. What he did is he stacked containers, plastic containers, which are held for these cans in supermarkets. But this is not what you see, but it's similar to that. So automatically you get something stackable, and then air automatically goes through it. And then the other thing is he told it's free. I mean, he wanted to reduce the cost. The plastic things were free. So he put it inside another water container, bigger tank, and then it also had facility, I mean, space for air to go around. Essentially, atmospheric air is always present for the system. And he got some lava rocks which are very porous, very lightweight, which has large surface areas. So all the things which you need for a biological action to take place is there. So you just trickle the water from the top. It goes down uniformly to about 14 layers, and then the water which comes out, he just put it into a big tank where fish is there. Okay, so this is the level to which this trickling filter can do. The benefit of the trickling filter is, I'm sorry, I went a little through the. This is actually activated sludge. I got a little carried away. I went to the trickling filter. Okay, activated sludge process. Yeah.
Secondary treatment. Secondary treatment is the heart of the wastewater treatment process. Whereas the previous steps of treatment consisted in removing the Secondary treatment. Secondary treatment is the heart of the wastewater treatment process. Whereas the previous steps of treatment consisted in removing the suspended solids by settlement, this step of treatment consists in removing the major part of dissolved pollution, mainly BOD5 and ammonia. During the aeration phase, specific bacteria eat the dissolved organic matter and transform it into suspended solids. Other specific bacteria oxidize the ammonia into nitrates, then nitrates. During the non-aeration phase, called also anoxic phase, other type of bacteria convert the nitrates into nitrogen gas, which is released into the atmosphere. To ensure a good balance between food and bacteria, the bacteria settled in the clarifiers are continuously returned at the inlet of the tank. They are called return activated sludge. The upstream part of the activated sludge tank is covered so that odorous air is trapped and extracted towards odor treatment units.
Yes. So
are we adding the bacteria or is it already present there?
bacteria, which is already, that is initially, thanks for the question, they call it seeding the tank, just like how you make curd, no? They take a little bit of activated sludge from an existing facility and then they start it. Again, once the bacteria starts to thrive, if suppose organic loading is lesser, then the bacteria will start to die. That's why you take a little of the sludge and recirculate it according to this flow diagram. Okay, so basically it's a very effective process, but then yes, I'll come to the problems. I don't know if I have put the problems. If I have not put it, I will tell you. So these are the variants. These are the add-on features which you can give to your activated sludge process. Okay, it's like putting something more to your motorcycle to make it more attractive, more lights. Okay, so here what happens, you can have a aerobic reaction with a preliminary treatment. Some sort of preliminary aeration is something you can do probably, because this is an aerobic process throughout. End to end it's an aerobic process. Towards the end probably you have what is that floccity, the kind of bacteria which can be both in aerobic and anaerobic conditions. I am not able to get that thing, but so this is the only thing which is there in ASP. No anaerobic bacteria is there. Okay, so the next is the oxidation and an oxidation ditch. Okay, this will yeah, I know it's just not coming to my into my mouth, so I will leave it at that. So it was there in the last lecture. So then yeah, so you had an oxidation and an oxidation ditch. In the in the previous video, you saw that there was a long blue thing with some circular thing, right? So actually, it's an oxidation ditch. Makes the water go round and round, so that it has an increased contact time. Okay, so this is something which you add to your activated sludge process. Okay, and then you also have contact stabilization. Okay, so where you have this colloidal and insoluble BOD alone removed from the liquor. Okay, so this will be done by a combination of adsorption, okay, and then some flocculation, and this will be done with a very little contact period. That will be done in a very rapid process. So this is called as contact stabilization. Okay, something like it's a mix of other systems which is being put into this, where you have probably some activated carbon also added for getting a layer of, where you can absorb some of the substances, and if suppose you want to have some flocks done, you can do that. So essentially anything that promotes this activity, so it just makes it faster. You also have high rate systems. Okay, that means the problem with high rate systems is the removal rate will be much lesser. For example, it will be around 15% of BOD removal that is done. Others will be 30 to 50%. But this one will be the rate at which the influent comes and goes out will be high, but the quality is much lesser. Okay, so then you may also have some modified aeration. Here you saw some paddles rotating for aeration. So sometimes they can have compressed air and then compressed air and paddles, because this will be just like your fish tank. The fish tank, you will have a stone like thing which if you put that compressed air in, it diffuses with bubbles. So that is one system of aeration, but there you'll have pipes of compressed air with the air diffused, and then they'll also have paddles to make the air mix more thoroughly with the liquor. So this is again oxygen aerated sludge. Instead of just giving air, they may give pure oxygen also. Okay, so that it is everything enhances the performance. That's the basic thing. Okay, so here I got a case study of a commercial system, but yeah, activated sludge process might not be very successful in all places, because if it's very cold and all that, the microorganisms will not be as effective as the other things. So this also applies to trickling filter, and in many of the cold countries they are actually banned. And in one of the subsequent videos, a person is trying to make the system viable for even cold places, because this is a very good and very effective.
The CE705 demonstrates the most frequently used biological wastewater treatment process, the activated sludge process. Due to the relevance of this process, we've attached great importance to a very practical and professional design. The main component of this process is the activated sludge, which is an accumulation of microorganisms. To prepare the experiments, activated sludge has to be taken from a domestic wastewater treatment plant and filled into the aeration tank of the CE705. Artificial wastewater is prepared in the laboratory to simulate average contaminated domestic wastewater. After the desired oxygen concentration has been adjusted, the aeration can be started. Under aerobic conditions, the microorganisms degrade organic matter and nitrify ammonia to nitrate. To enable also a denitrification, an anoxic section is installed in the aeration tank. As the activated sludge is suspended in the water, it is discharged continuously from the aeration tank. Therefore, the effluent of the aeration tank is fed into a secondary clarifier. The aim of secondary clarification is to separate the activated sludge from the water by means of sedimentation. While the activated sludge is returned to the aeration tank, the treated water is collected in a separate tank. The software of the CE705 enables comprehensive process monitoring even with integrated video surveillance capabilities via network. To evaluate the experiments, specific parameters have to be determined using water analysis systems. The CE705, learning the activated sludge process in all its aspects.
So this is one product which they talk about, but when you study the different product lines, you get all the merits or what, like they try to compare how they are better than others, and in other words you also get to understand the problems which are there. And also of late, like every industry wants this supervisory control, as in from one place you sit, you see what is happening, video cameras. In fact, look at the number of cameras which are there in VIT. Every computer lab, in fact you go and have a look at it sometime, even in the dark room they are able to see and monitor all movement and everything. So one place, instead of having 100 guards, you are now able to do it with say 2 or 3 people who can have a cup of coffee and also do their work, which was not actually possible earlier. Now what do I want to tell here is, in I was with an EPC contractor, so they installed these crushers. Now what they want is, they don't want just crushers, they don't want a motor switch like just a big black button like in your fluid mechanics lab, you press it, it turns on. Nothing of that sort. They want everything to be done from one room. This crusher, however remote it is, it has to be controlled from one room. So what controls you expect is to be all push, like you want something to go more than they want to just touch it and see. And if something is wrong, they wanted to show some indication on that itself. Like you got your move and all that spray, that they put red color dots. If you have pain here you do. So like that they want it in the crusher diagram. So oil is not flowing, then you highlight it, and then you go and click it, press it, it says oil is not there. So same thing is happening even to your cars, right? Now earlier we only think Tata is that old sort of car. But now what they do, they plug in something and only the computer or laptop says this is wrong, people know. It's not like before where you just open the bonnet and say yes, this is wrong, that is wrong. So this is how things are going. In fact, when we are also giving a product, you as civil engineers, you may have to think how to integrate this sort of thing into your buildings. Fire is not there or water is not there. This is how things are evolving. And probably we as faculty members in a university, we have to give products which will be able to design such systems. Like think that it has to be done in a way which is very easy. Just imagine any game you buy or any operating system also, you want it to be so intuitive. Just you take your mobile phone, you should be able to understand what is there, right? So this is what this is the way the world is coming to. And this is the trickling filter about which I was so excited about. Okay, so it is also an aerobic process. Influent passes over media. Aeration is forced or natural. Okay, that is, it can be just in natural aeration or it has to be in contact with air. That's all. Finished. Okay, so here is a fixed nozzle system. Okay, where the nozzles are just there. You just spray it and water will go into the trickling filter, and then there will be all the bacteria on the surface of that filter media, and it will also eat it will decompose the nutrients which are there in the liquor. This is a rotating arm system. So what actually happens is area is much lesser than your rectangular systems, and because the arm rotates over this, by the time it finishes one revolution, you will find that the water will have gone down. So it will be just correct, the rate at which you are loading the system. Okay. So here there is a system. Just see, this system is working without electricity.
These were part of the original design of this plant. This plant's been upgraded a couple of times since it was originally constructed. It's pretty amazing to me to see all that big steel structure right there. There's no electric drive turning that around or no motor. That's all spinning just from the
water has enough
water pushing it around.
Really?
Yeah, that's pretty amazing, I think. It's pretty amazing. But at any rate, the rocks in this trickling filter are about 6 feet deep. Underneath the rocks there's a support structure and then an open channel underneath that. So the water's going through and in that channel at the bottom. You can see if you look at the distribution arm there's a lot more water coming out at the end than there is towards the center. And that's because if I took a 1 foot wide section and followed it all the way around, there's a lot more area on the outside than there is on the inside. So if I want to put the same amount of water everywhere, I have a lot lower flow towards the inside, so I get the same amount of water.
So this is the trickling filter. One of the points they told was, you can't load the water same from the center to the outside, because the periphery has more surface area. So water flow should actually be more in the outside than in the inside. Okay. So here another video is there. These are done by a couple of students. So I love this the way they do. They bring out a lot of points, and especially many of these in fluid mechanics and all, I've seen many videos. So those are really interesting. Okay. But anyway, these students are doing only for the trickling filter. It has a little bit of the math and all that.
Welcome to Science Facts! Today we will investigate the world of wastewater treatment. Now tell me, do you know anything about trickling water filters? No? Well, they're the secondary step of wastewater treatment. Interesting. Actually, trickling filters have been used in the 1900s. It is only in the 1950s that the Dow Chemical Company developed the first prototype based on mathematical calculations. Trickling filters continue to evolve, although they are not commonly used. Alright, let's start with an explanation of the trickling water filter technology. Okay.
A trickling filter consists of a fixed medium, on which bacterial film grow in mostly aerobic conditions. The biofilm digests the wastewater, which leads to a reduction of the biochemical oxygen demand and some nitrification. The medium needs to have certain characteristics, such as low bulk density, to permit air from going through the filter, and a porous material to have a good bacterial growth. To function properly, a trickling filter needs nutrient-rich wastewater, good aeration without forced ventilation. There needs to be enough shear force to remove the excess biofilm to avoid clogging of the system. Many organisms can live in a trickling filter, such as bacteria, fungus, protozoa, and other unwanted organisms such as algae, flies, larvae, and more. The biofilm needs to be kept moist at all times to digest properly the wastewater.
Donc, quand la cellule est en filtration, on envoie l'air de procédé. Donc, l'air sort comme ça, pendant que l'eau, elle, tombe dans l'autre sens. Ça, c'est l'air de lavage. Okay? Donc, quand le lavage est déclenché, la porte se ferme, il n'y a plus d'eau qui rentre, l'air de procédé arrête. Et là, on envoie l'air de lavage. Et généralement, on fixe un temps de 2 minutes. De brassage, uniquement de l'air. Ça, c'est pour essayer de briser, justement, tout ce qui aurait pu se former comme biomasse dans ta cellule. L'air, lui, n'arrête pas, il continue. Après un certain temps, c'est l'eau de lavage qui va venir en jeu. Il y a une pompe qui lui récupère l'eau dans la bâche centrale, donc l'eau filtrée de toutes les autres cellules, et qui renvoie en contresens dans la cellule. Ce que je peux jouer, c'est l'air de procédé. Je peux jouer sur le débit, puis je peux jouer sur le lavage. Donc, on choisit la granulométrie de telle sorte à ce qu'on ait une filtration qui est efficace, mais aussi que l'eau puisse passer efficacement. Parce que si, par exemple, on avait mis un lit de sable au lieu d'un lit de schiste, on serait incapable de traiter. Là, et ça se colmaterait, parce que de l'eau usée, c'est hyper chargé. Là. Ça se colmaterait beaucoup trop vite. Donc, le lit de schiste, c'est parfait.
We will compare low-rate trickling filters and high-rate trickling filters to understand the major differences. There are fewer nutrients available to the bacteria in a low-rate trickling filter. This causes partial stabilization of the sludge and a larger removal of the biochemical oxygen demand. High-rate trickling filters can afford to be deeper because of the low density of the material used. Artificial granulates instead of materials with a high density such as stones are used in this type of trickling filter.
C'est une technologie qui est simple,
Okay.
qui est pas énergivore.
Mais idéalement, quand on construit un système de traitement biologique, l'idée de base, c'est d'utiliser le moins de produits possible pour subvenir à ton traitement. Parce qu'on s'entend, le physico-chimique, c'est hyper efficace, OK, mais tu dois toujours injecter des produits.
Respecter scrupuleusement les données d'ingénierie pour faire le design. Il ne faut pas surcharger le filtre, parce que dès qu'il y a trop d'apport d'eau usée, finalement, pour une surface donnée de filtre, ce qui va se passer, c'est qu'il va y avoir trop de croissance de biofilm et on va colmater notre biofiltre à ce moment-là sur le plus.
Moi, je pense qu'il y a beaucoup de potentiel sur ce système-là. Donc, avec l'étude que je fais, j'arrive à déterminer, à mieux le comprendre, en fait, pour que les futurs systèmes de traitement de ce type-là soient mieux conçus. C'est là toute l'idée. Ultimement, suite à mon projet, on remettrait sur la carte ce type de technologie-là qui est interdit maintenant.
Oh wow, we learned a lot today. Thanks for watching us and don't forget to tune in next week.
Hi, I'm Eric Smith, and well, this afternoon we're out at the Edmond Wastewater Treatment Facility, and with me is Chris Knifing. Chris is the chief plant operator here at the facility.
Yep.
Is that correct?
That's correct.
And you know, very often a lot of us take for granted that when we put something in the sink or flush something down the toilet that it's just gone. But this is actually where anything in Edmond comes and it gets, I guess, refined and sorted out and turned into, I guess, potable water, I guess, for all intents and purposes.
Close to potable
Close,
water.
okay.
Close.
Makes it safe for the rest of the community.
Right.
Now, where are we right now? This is point A. I guess this is where it starts.
This is the plant lift station where we take about half the flow from the city of Edmond.
Okay.
Around 3.5 million gallons a day come through here.
Wow, every day.
Every day.
And you know, I've noticed this. Can we take a look at this? What is this?
This is what we call a bar screen.
A bar screen. Okay.
It's screening objects larger than 1 inch.
Wow. Look at that.
Yeah, yeah.
There's stuff in there.
There's lots of neat stuff that comes down the line.
That's interesting. Now we have a what, a 24-inch line, I believe, that comes in here, and so this screens out the big stuff.
Right, screens out the big stuff, and then we head into the wet well, which is actually
wow, look at this.
A bit of a sump.
Huge.
And then from here, we've got 3 pumps inside the lift station that are conveying water uphill.
Okay, now what does this actually do? Once it gets screened out and it's in here, what does this do?
This is just a sump for to hold water for the pumps.
Okay,
so they'll have something to pump out.
You know, Chris, one of the things that I find very interesting is we're standing right above wastewater, and interestingly enough, there's absolutely no smell.
Right.
That surprises me because I thought surely this is going to really be pretty rank. No smell whatsoever.
No, we add chemicals into the water, ferrous chloride, to treat for the sulfide smell or rotten egg smell.
Okay. Okay, Chris, we've just walked up 200 or 300 yards from the entrance point, and now we're at a head unit that you're saying is a fine screen area. Is that right?
This is the headworks of the plant, and what we're doing here is screening out even finer objects. So down at the bottom we were screening 1-inch objects, and now we're down to 1/4 of an inch to get even finer trash from entering the plant.
So it just sifts out even smaller and smaller pieces.
Absolutely.
Okay, what is this? This is step number 3, I guess.
Right. This is called an oxidation ditch. This is where we've got microorganisms that are actually breaking down the pollutants in the water.
Okay. And that just simply, that's another step. It just breaks it down, and the microorganisms in here just, eat at it? Kind of like, I guess, at home, if you have a block of cheese and if you just let it sit there, it would get moldy and it just end up breaking down. And that's what's going on here.
Right. We've got them concentrated and give them air. You know, just like fish, they need air.
Yeah.
And just send them around, and it's about a 24-hour detention time to break all the pollutants.
It takes about
down.
24 hours, and this just kind of goes in a circle, doesn't it? This water just rotates around.
Yeah, another name for an oxidation ditch is a racetrack, and it literally
sense.
it looks like a racetrack.
Okay, now I'm seeing some like big bubbles. What are those? Those big plastic looking?
Yeah, when people flush grease down the drain, it comes in here to the plant, and it's hard to break down, and so you see the bubbles, they'll stay up on top, and that's actually grease.
Wow. Okay. Not a good thing to be putting down the drain, though, right?
No, never is.
And that's the reason why is it's hard to break down.
Absolutely.
Tell me, what are some of the things that citizens that we can do to make your job a little easier here? What can we do to help you out?
Well, you know, things like flushing grease down the drain, plastics, personal hygiene products, paper towels.
Paper towels?
Paper towels.
I wouldn't have thought that. I would have thought that would break down, but paper towels don't break down.
No. They stay intact and actually form balls of rags, which can actually clog sewer lines.
No kidding.
Absolutely.
Okay. All right. That's interesting to know. All righty. We've just taken a look at the oxidation ditch and how that works. Now the next step is, you said, the clarification tank. Is this what this is called?
Yeah, these are clarifiers, and so after it's leaving the oxidation ditches, the microorganisms, we bring them in here to settle out the sludge or microorganisms.
You know, I'm noticing that this, the water on the edges, it kind of flows over the edges. This is very clean water now.
What's happening here is the sludge is settling out, and the good water, the good clean water,
It's coming to the top.
is coming over the edge and leaving the clarifier.
Kind of like at home when you get dirty water and you let it set, and it's just sediment goes down to the bottom and clear water's at the top. Because I can actually see down into this, but there's sludge at the bottom, right?
Absolutely.
About how much?
Well, let's take a look.
Oh yeah. Hey, great. Let's take a look at this. Okay, now what is this? It's a big long plastic tube.
This is we call it a sludge judge. It takes a core sample of the water,
Okay.
so we can see exactly
You
how
run
much.
this down to the bottom just like when you're a kid, you get a straw and you put it in your Coca-Cola and put your thumb on it and pick
Absolutely.
it back up. And that's
Same.
it. Look at that.
Same concept.
Wow. Okay, so you've got 1, 2, 3, about almost 4 feet, 3.5, 4 feet of sludge.
Absolutely.
Okay, interesting. Wow, look at that. And then that's the clear water that comes out of it.
Yeah.
Oh, that's interesting. Okay, now after this, then we've got another step because it gets even cleaner.
Yeah. So we have little fine solids that'll actually make it over the weirs of the clarifier.
Okay.
And so our next step is to take it to a sand filter and get it down to just a little
Teeny
bitty.
tiny. Okay, where's the
Little bit.
sand filter?
Well, let's head there.
Okay. Okay, Chris, I guess we're at the last phase of the water cleanup. We've just finished with that part. Now we're going into here. What is this?
Yeah, so from the clarifiers, we're heading into sand filters, which is just polishing fine particles that may have escaped the clarifier,
Okay.
and to screen them out, basically.
Okay, and what's in the bottom? What's the filter?
There's 30 inches of sand in there before it can release through the bottom. It's all gravity draining down through the sand.
So the sand is a natural filter, and the water just gets pumped in, and then gravity pushes it down and
Absolutely.
comes out into here. Let's go take a look
Okay.
down in here. A lot of white bubbles in here. What is this?
That's just from the oxygen in the water. It's just churning it up, kind of like if you turn on your faucet real fast.
Okay, wow, I can smell this now. But this is a good smell. This is the very first time I've been able to smell something. It smells like chlorine.
Yeah, just like a swimming pool, same thing.
Okay, so you chlorinate this water.
Yep.
Okay, and as I can see, it's flowing through here, and you've got a maze. What on earth does this do?
The maze is to make the 30-minute contact time required to kill pathogens in the water.
Okay.
And instead of letting it run straight through, it has to wind through a maze to make sure it has its
Slows the
contact
water
time.
down.
Absolutely.
Okay, so you've got chlorinated water coming in here. By this time, the water is pretty darn clean. At this point,
Absolutely.
right?
Yeah.
Okay, now let's go ahead and go on down here. So the water is being slowed down by these baffles. Oh, this is interesting. Okay, we've got something going on down here. What's going on down here?
Well, here we're dechlorinating the water to keep from killing fish and other microorganisms in the habitat where we're discharging out into the creek.
Okay, so now you have to dechlorinate because the next step is what? It's going to get pumped out into nature?
Right, it just goes straight out into the creek,
What creek?
the Coffee Creek.
Coffee Creek.
Yeah,
Can we go take a look at where this comes out?
sure. Let's go
Okay,
take a look.
great. Okay, so Chris, wow. Okay, this, now you said this is Coffee Creek, right?
Right.
Okay, this is very, very clear. I can see the bottom of the creek. It looks like in places, looks like it's 6-8 feet deep in some places here, but this is so clear. Now, this is as clean as it gets because you're putting the water from the wastewater treatment facility into the environment, right?
Right.
And this is clean.
Yeah, this is clean, and as a matter of fact, we monitor upstream and downstream twice a month to make sure that our water is clean, and we're actually cleaning it up. It's cleaner after we put water into the creek than before.
Oh, really? So the water you're putting into the environment is cleaner than the water that's already there.
Absolutely.
So in essence, you're helping the environment.
Absolutely.
Oh, this is incredible. So we've gone from all the way from A to Z, and this is the very end of it. This has been very interesting. Chris Knifing, I really do appreciate you letting us come out and take a look at this. For our viewers back home, be sure and remember, make this man and his crew's job easier. No grease in the drains, and only put the things that really belong in the toilet. And this has been so interesting.
This has been a segment from a previous episode of Your Edmond. Watch new episodes of Your Edmond beginning each month here on Edmond Life TV.
Both of them, the work they do is the same, but the way they do it is different. Clarifier, that was a huge round tank, where the heavier materials just settle down, and actually what happens is that quiescent condition what we talk about, where there is no turbulence, nothing, that is achieved, and it's quite long, like all the directions, it's since it's circular in all the directions from the central discharge point is the same to go to the periphery. So material as the water travels towards the periphery, the particles settle down. Heavier,
You're talking about the
clarifier. So heavier particles will settle down faster. Those which are lighter will go a little further down and settle. Then it overflows. Actually, that's something I wanted to see. We were talking about overflow over the vias, right? This is what is meant by that overflow over the vias. You can see it more clearly in this video. So it gets collected in that outer chamber, and it is all going to the next step, which is the sand filter. Sand filter ensures that anything which is left out by the clarifier is still caught up. Essentially, that initial oxidation point, whatever we have, that is like your activated sludge process. Essentially, just a tank where you have some.
So will be both the sedimentation tank and the clarifier, or will be just either one?
It depends. It depends on how much you are looking at the quality. That's all. If you want to say that clarifier is enough, clarifier is enough. But the quality will be that much. There are also rectangular clarifiers. There are also in that center. Huh? You can see sedimentation tank. Yes, clarifier and sedimentation tank are the same. Only that's. Oh, you are asking whether sedimentation tank and clarifiers are same, right? Okay, your answer is yes. To your question, the answer is yes. I was thinking you were talking about sedimentation tank plus sand filter. Yeah, both the same. Just that in a rectangular one, you'll have a central channel over which it overflows and then goes to the periphery. Okay. Then again, we saw the baffles where that chlorine was added. 30-minute detention time is ensured. They dechlorinated, and then they also went for. That's the main process. Now today, whatever you saw, activated sludge process, that oxidation ditch, all those things were seen in this video form, as in how it is put in a real wastewater treatment plant. Okay. Now, basically these are the links which I used. These are the references. And do you have any other doubt in these processes which you saw? Activated sludge process and trickling filter. In fact, trickling filter was not used here. Okay, trickling filter, it will take a little longer time probably to trickle down and go. But no, I won't say it takes a longer time. It's just that it depends on how you design your system basically. And trickling filters are also very efficient, and activated sludge process is also very efficient because the amount of energy required is very less in both these processes. It just is that you will have to take a call, like why trickling filter. You can just see the merits of trickling filter. That's why I want you to write your assignments with a focus that you understand what is the principle, what is being removed, when is it efficient, when will it not work. The moment you know all this, you can take a choice call on the system based on the influent characters, and also you can also see how you can dovetail with other things. What do you mean by dovetail? You can just match it with the existing wastewater systems. Okay. So I will say thank you and stop now. We will meet again in 5 minutes. Okay.